All right, so this is going to be problem 7 out of chapter 9. Let's just read it real quickly. 2 chords support a chandelier in the manner shown in figure 9.4, except that the upper chord makes an angle of 45 degrees with the ceiling towards the left if you don't have the book. If the chord can sustain a force of 1660 newtons without breaking, what is the maximum chandelier weight that can be supported? All right, so I have a very generic set of steps to solve any problem like this, but just take it and apply it where you can. So the first step is just to draw the free body diagram. The second step is to, after you have to identify the forces there, right? And then you want to use F equals ma, which is just Newton's second law, to describe all these forces, whether they're weights or not. And once you figure out all the givens based off of the weights in the problem or newtons given in the problem, then you can start to solve for unknowns by summing the forces using the sum of the forces equals ma in all those situations, whether it's 0 at equilibrium or if it's non-zero, which is just not equilibrium. It's a little bit harder to do, but it's doable as well. So let's get into it. This is what the free body diagram will look like. So it's one idea to make the chandelier the center of our free body diagram, but then we'd only have tension in the string this way and gravity this way, and it wouldn't be moving, so we would only find out that tension is equal to gravity, which isn't very useful for us. So instead of saying that the chandelier is at the center of mass, we're going to say that the junction that connects the chandelier to the walls is where we want to have our free body diagram, where all the forces are acting on. So we're going to have a force, like we said, 45 degrees off the horizontal on the northwest side, of a B force pulling to the right, and then weight pulling downwards, right? This is just weight. And with all this, we can see that we have so this is a completely X force, completely Y force, and this is a little bit of a mix of both, right? So what we have to do here is break it into a component. So actually we want an X component here, and we want a Y component here. This is going to be FAY, this is FAX. And so if we make a little triangle just for that, have our 45 here, 90. This must also be 45, right? This is FAY, this is FA, this is FAX. And so we can see FAX is equal to FA cosine 45, FAY is equal to FA sine 45, and these are just square root of 2 over 2, right? So it's about 1.4, but I'll just leave it as a trig function. I think it'll be easier that way. All right, so closest cosine when we do adjacent over hypotenuse, that's what gives us this. And then, yeah, you should know SOHCAHTOA by now. So SOHCAHTOA for trig functions. Now that we know what our forces, all the forces we have, let's just identify. So we have one force in the y, in the positive y, and one force in the negative y, one force in the positive x, and one force in the negative x. So now we can balance this out and figure out what the weight is, right? Because we do know that we know that something is 1660 newtons, and we know that another thing helps to hold up the 1660 newtons. So we have to figure out which force is which, but let's deal with that next. So, like I said, this will be like a step 2. You can start to use Newton's second law. So we talk about only the x components. Then we have sum of the forces in the x is equal to the positive x minus the negative x. This is equal to 0 because the chandelier is in equilibrium. And with this, we can just move FA cosine 45 to the right side. And this basically means that FA is going to be bigger than FB. Yes, this is going to be bigger than FB. And then because we know that it's going to be bigger than FB, we have to set FA equal to 1660 newtons. And with that, when we go to the y, we can sum the forces in the y direction, and we have the y component of FA positive and the weight as negative. So the weight is just equal to whatever the y component is. And this is just 1600 times sine 45. So it just turns out it's 1174, or to put it roughly, about 1200 newtons.